Hello everyone, I am Suraj and here is the question of the day. So in this question we are given an array of ranks and an integer cars. So what does this ranks array represent? So in this ranks arrays it is an array of mechanics where ranks is the ith mechanic, okay? And these mechanics need to repair all the cars. There are total number of cars, the mechanics need to repair all of them. Secondly, we need to return the minimum time taken to repair all the cars, and there is a note that all the mechanics can repair the car simultaneously. So first, let's understand the question first. So we are given an array and a number of cars and a formula that it is the time taken by a mechanic of rank R. R is an element of this array. It can be 4, 2, 3, 1 in this case, and N is the number of car it is repairing. For example, let's see. Let's make a table. Yeah. So let's say we are talking about this 4. Okay. So let's take 4. And if this mechanic is repairing one car, so how much time will it take? It will take, what is the value of R? That is 4 into N into N. In this case, N is 1. It is repairing one car. That is why N is 1. So 1 will be 1. So it will be equals to 4 only. So it means this mechanic in 4 minutes will repair one car. And if it wants to repair two cars, how much time will it take? It will be R into how many cars it need to repair? 2 into 2. So 2 into 2, 4, 4 into 4, 16. So it will take 16 minutes to repair two cars. Now let's say it have to repair three cars. So how much time will it take? R, that is 4 into 3 cars into 3. 3 into 3, 9. 9 into 4, 36. So 36 minutes it will take to repair 3 cars. So that's how this formula is working. It is just showing the time taken by a mechanic of rank R to repair n number of cars. Okay. So next there was a note that all mechanics can repair the cars simultaneously. So let's understand what it is. Let's say what are our mechanics? 4, 2, 3, and 1. Let's say there are 10 cars. If I want 4, you have to repair 3 cars. 2, 2, it will repair 2 cars. 3 will repair 3 cars, and 1 will repair 2 cars. Okay. In total there are 10 cars, and I allotted 3 to 4, 2 cars to 2, 3 cars to 3, and 2 cars to 1. So how much time will 4 take? It will take 4 into 3 into 3. That is 3 into 3, 9, 9 into 4, 36 minutes. Now, how much time will it take? 2 into 2 into 2. So it is 8 minutes. Next, 3 into 3 into 3. How much time it is? 3 into 3, 9, 9 into 3, 27. Next, 1 into 2 into 2. So it is 4. So it is saying that all those mechanics can work simultaneously. What it means, like, so what will be the answer for this case? The answer for this case will be 36, because it is the maximum time uh, one mechanic is taking to repair all the cars allotted to him. All the other cars are taking lesser than time him. That is why the maximum time taken by any of the mechanic will be our answer. So now you have understood the question. So now let's see how are we going to approach this question. So in this question, we are going to use binary search. How binary search? We will see. I will split this question into two parts. First of all, I will give, I will guess a value. Second thing, I will see it is a possible solution or not. Okay, just as any of the binary question I have thought before, it is just similar to that I am first of all guessing a value and then I am saying whether it is a possible solution or not. First of all, we will go for the harder part, that is the second step, and look how it will be implemented. When I am saying that whether it is a possible solution or not, what do you mean by that? It means that in that particular time, all the mechanics should be able to repair all the cars. So how can I find that out? So let's come to this formula again. It was saying that time taken is equals to R into R, R into N. Okay. So this N, if I want to see that in a particular time, how many cars are repaired by a mechanic. So how can I find it out? I will just reverse this formula and we'll say that N into N will be equals to T divided by R. It's simple maths, that N square will be equals to T divided by R. Okay. Now I want to find N. So N will be equals to the square root, N will be equals to the square root of T divided by R. So that's how I can find the value of N. And let's say there are four mechanics, okay? And my guess value is, let's say I am guessing the value to be 20. Okay. Now, how I'm going to do it? First of all, my guess value is 20. It means the time taken by all the mechanics is 20. First of all, I will check for the first mechanic. The value for first mechanic is 4. Okay. And how many cars it can repair? This mechanic can repair in 20 minutes. Okay. So how can I find it? I will just divide it by and take the square root of it. So what it will be equals to 20 divided by 4, that is 5, and the square root of 5 is around 2.2. I will convert it into the integer, so it will be equals to 2 only. Next, the next element is 2. Okay, so square root of 20 divided by 2 will be equals to square root of 10. What is the square root of 10? It is around 3.1, and that will be, it is 3.1, and that is almost equals to 3. Next is 3. So I will take square root of 20 divided by 3. That will be equals to square root of 3 divided by 20. 20 divided by 3. That is around 6 point something, 6 point around 1 or 2. And it is around 2.3. Around 2.3 or 2.4. And it is equals to 2. If I convert it into the integer, it will be equals to 2. My next element is 1. So if I take square root of 20 divided by 1, it will be equals to square root of 20 only, and which will be around 4 point something. And if I take integer of, then it will be 4 only. Now I have 4 values. First one is 2, second one is 3, third one is 2, and fourth one is 4. It means in 20 minutes, first can repair two cars, second can repair 3 cars, third can repair 2 cars, and one can repair 4 cars. If I take sum of all this, why to take sum of all this? Because it was mentioned that all can repair all the cars simultaneously. It means all those 4 mechanics can work simultaneously, and after 20 minutes, how many total cars after 20 minutes, how many total cars they will be repairing, that will be equals to the sum of all those cars which they have repaired in 20 minutes. So it will be 2 plus 3. Let's calculate it. It's 2 plus 3 plus 2 plus 4, and it is equals to 5. 5 plus 2 7, 7 plus 9, that is 11. Okay, so in 20 minutes they were able to repair 11 cars, and we need to repair 10 cars. It means that they can repair more than the cars required to repair. So it means it can be a possible solution for our answer. Okay. So now let's take one more example. If I take it to be 9. Okay. So first of all, for 4, this time I will be doing it a little bit fast. So our it was 9. 9 divided by 4, it will be around 2, and it will give me 1. Next one is 2. Square root of 9 divided by 2. 9 divided by 2 is around 4. 4 will give me 2. Next one is 3. Square root of 9 divided by 3 is 3, and it will be around giving me 1, and it's 1. So square root of 9 divided by 1, it will give me 3. Okay. So let's see, if we count these four numbers, then 1 plus 2 equals to 3, 3 plus 1 equals to 4, 4 plus 3 is equals to 7, and it is giving me 7. It means these four mechanics can repair 7 cars in 9 minutes. Is 7 greater than or equals to my required cars? No, it is not. That is why 9 cannot be a possible solution for us. I hope you understand this. So how are we going to use the binary search here? Let's understand that. We need two things. First one is the minimum possible answer, and the second thing is the maximum possible answer. In order to find our range, we need these two things. So in this case, what will be our minimum possible answer? So it will be at least 1 minute. One will be a safe option for us. And what will be the maximum? The maximum will be the maximum time it can take is, let's see, what is the maximum value in this question. That is for, what if I allot all the repairment of the cars to only one mechanic, which takes the maximum time. The 4 is the one which will be taking the maximum time to repair a single car, so it will be taking the maximum time to repair all the cars as well. So our maximum time can be whatever the maximum element of the array into the number of cars it need to repair. If you don't understand that how the 4 is taking the maximum time, so just say this formula. This formula is saying that the time taken is equals to r into n square. This time is directly proportional to two things. First one is the r, the value of r, and second thing is the n square. It is the number of cars. The number of cars is okay. It means the more number of cars there will be, the more time it will take. This r, represents the capability, the ranking of this mechanic which is taking the time. If this r is more, the time taken by the mechanic will be more, and that is why I am taking the maximum element of this array and multiplying it with the cars. It will be giving me the maximum possible answer. So now we know two things. First one is the minimum and second one is the maximum. So let's do one thing. Let's plot our graph. So we have a range. Okay. What is the maximum possible answer? What is the maximum possible range of this question is? It is starting from it is starting from 1, and it is ending at, what was the maximum element? 4. And what were the number of cars? 10. Sorry, it will be cars into cars, because the maximum time taken is r into n into n. Na? That is why we are taking n cars into cars. So what will be the maximum possible answer? That is 400. So at first what we will do, we will find the mid of it, and it will be around 200. See, we have done this question for 20, so we know that all the values that are greater than 20 will be a possible solution for this question. Okay, so I will not be calculating it for 20. I know that 20 is a possible solution, because if four mechanics can repair 10 cars in 20 minutes, then obviously they can repair those 10 cars in 200 minutes. Okay, so we need two pointers. The first pointer is at the maximum, and let's call it left and right pointers. It is the right pointer. Okay, so I know this 200 is possible. It is a possible solution for us. So when I know that it is a possible solution, then what I will do, I will store that possible solution in a variable. Okay, so let's call it answer, and I know 200 is a possible solution for us. And when I found a possible solution, what I will do, I will take this right. I will take the right and put this mid minus 1. So by this time, what is my left? My left is 1. My right is 199. Okay. So what will be my mid? The formula for mid is the left plus right divided by 2. You all know binary search, so you know that the formula for mid is left plus right divided by 2. So what will be my new mid? It will be 1 plus 199 divided by 2, which will be equals to 100. So just take this mid, take it here around, and now my new mid is 100. Okay, so I know that solution was possible for 20, then it will be possible for 100 as well. See, in the code, it will be calculating again and again for that. But when I'm explaining, I know that I have solved this for 20. So it will be applicable for 100 as well. That is why I'm not solving. It will be a wastage of time. So we know that it will be possible for 100. So I will take this right pointer again, put it 100 minus 1. It is just mid minus 1. Okay. So what will be my new left? My left is 1 only, because my left has never changed. My right has become 99. So what will be my new mid? My new mid will be 1 plus 99 divided by 2. So it will be 50. Okay. So just take it, put it here around, and now the value of my mid is 50. Okay. So 50 will be a possible solution for us. Yes, it will be. So I will take again my right and put it mid minus 1. So again, my left will remain unchanged, that is 1 only. My right has become 49, and my mid has become 1 plus 49 divided by 2, that is will be 25. So I will take my mid, put it here, change it to 25. Now again, is 25 a possible solution for us? Yes, it is, because I have solved it till 20. So 25 will also be a possible solution. So I will take this, put it mid minus 1. Now my left will remain unchanged, that is 1 only. Right will become 24 this time, and my new mid will become 1 plus 24, that is 25 divided by 2, that will be around 12. It will be converting itself into integer. So it will be 12. Okay. So now it's 12. Just change it to 12. Put this here. So is 12 a possible solution? We have not checked yet. So we will sing that. So let's see whether 12 is a possible solution or not. What were my options? Where is my array? It was 4, 2, 3, and 1. Okay. So first of all, just find out square root of what is the time which I've given? 12 divided by 4. It will give me a square root of 3, which is around 1. Okay. Next, square root of 12 divided by 2, which will give me square root of 6. So what is the square root of 6? It is around 2 point something. So we will just take it 2 because at the end we will be converting it into integers. Next is square root of 12 divided by 3. So it will be equals to square root of 4. It will be 2 only. The next one is the square root of 12 divided by 1. It will be square root of 12 only. It will give me, what is the square root of 12? It is around 3 point something. So it will give me 3. So let's count it out. I will just take, sorry. So it is 1 plus 2 plus 2 plus 3. 1 plus 2 plus 2 plus 3. 1 plus 2 that is 3. 3 plus 2 that is 5. 5 plus 3 that is 8. So we have got the sum equals to 8. And what were the requirements? That was 10. So is 8 greater than or equals to 10? No, it is not. So it is the first time it is not a possible solution for. So what we will do when we are getting it that is not a possible solution, we will take our left, put it mid plus 1. Okay, mid plus 1. What was my mid? My mid was 12. So I will just put my left to mid plus 1 to 13. Okay, and my right will remain unchanged this time. So what will be my new mid? That is 13 plus 24. 13 plus 24. What it will be? 27, 37 divided by 2. I think it is around 18. Let's say 37 divided by 2. Sorry, 37 divided by 2. It is around 18 only. So my new mid will be 18. So now let's check whether it is 18 is a possible solution or not. Okay. So let's again do it. Let's do it a little bit fast. So I have done the calculations here. So these are the number of cars that are being repaired by the mechanics. So that are 2 plus 3 plus 2 plus 4. Let's sum it. 2 plus 3 that is 5. 5 plus 2 7. 7 plus 4 11. So 11 cars can be repaired in 18 minutes. Let's compare it with the number of cars required. So it is 10 and the number of cars that have been repaired that is 11. So it is greater than the number of car required. So it is a possible solution for us. And whenever it is a possible solution, what we were doing? We were taking right and taking it so mid minus 1. So my left will remain unchanged and it will be changed to 17. Okay. What will be my new mid? It is 13 plus 17 divided by 2. It is 15 divided by, sorry, 30 divided by 2. And it will be 15. Again, we have to check it for 15. So for 15, these are the positive, these are the number of cards which are being repaired. So let's sum it out. Plus 2 plus 3. It is 1 plus 2, 3. 3 plus 2, 5. 5 plus 3, 8. So these are the number of cards that have been repaired in 15 minutes. Let's compare it. It is 10 and the number of cards that have been repaired, that is 8. So it is not a possible solution for it, because we need the solution to be greater than or equals to the number of cards required. Okay. So it is not a solution. So what will we will be doing? We will take left and take it to mid plus 1. What was mid? 15 plus 1, it will be 16. So let's change it to 16. Let's check for 16. Let's change mid also. It is 16 plus 17 divided by 2. It will be around, sorry, 6. It is around 33 and it will give me 16 only. So for 16, these are the values. These are the number of cards which have been repaired. So let's sum it out. 2 plus 2 plus 2 plus 4. It is 2 plus 2, 4, 4 plus 2, 6, 6 plus 4, 10. So 10, is it greater than or equals to the number of cards required? The required cards were 10 and it is also 10. So yes, it is a possible solution for us. So in that case, what we will be doing? Put right into mid minus 1. So right will be again 16. Okay. Both of them are equal. Let's again calculate the mid. It is 16. It will be 32, and again I will get 16 only. I have checked for 16. It is a possible solution. So what I will do? I will put left to mid minus 1. Now the left has become 17. And in this case, my left has become greater than right. So when it will happen, I will just come out of loop, and whatever will be the mid, the value of mid, I will just put that as my solution. So in this case, 16 is my answer. And if we see the example, then output is 16 only. So now let's start the coding part. So first of all, we need a Boolean function which will tell me whether a particular time, under a particular time, it is possible to repair all the cars or not. Okay. So we will do that. And this is the time which under which we will be checking whether all these cars are possible to repair or not. So let's start. So what do we need to do? First of all, we will maintain a counter. Okay. Initialize it with 0. And we will check for each rank which is present in ranks. We will see that what are the number of cars it can repair. For example, in this case, this number 4 mechanic, how many cars it can repair? How we were finding it out. We were taking the square root of time divided by the rank of it. So we will do the same. What was the time? It is in time divided by whatever the rank it has. I will just convert it into double. Why so? Because whenever we will be dividing it by the rank, it will give me some decimal value, and in order to handle those decimal value, I need this double. Okay, and at the end, I will just say just add those repair into my count. Okay, and at the end, just return if my count is greater than or equals to the cars. If my count is greater than or equals to cars, then just return true, otherwise return false. Now let's come to the binary sort. First of all, my left was equals to 1. As I told before, my left was initializing with 1 and my right was initializing with the maximum element multiply the number of cards here. Okay. So we need to find the maximum value. Let's do one thing. Maintain a variable max and see what is the rank that is maximum. So we will allot max.max if that rank is maximum or this maximum variable is maximum. Whatever is maximum at the end, just put that into my right variable will be equals to cars into cars. That is the same we did here. Okay. Now I have my left, I have my right. So now I will just make a loop. Till the time my left is greater than or equals to my right, it will just keep on looping. Okay. And when my left is greater than right, I will just break it out. So next I need to have a mid. Okay. What was mid? It was left plus right minus left divided by 2. And it is a possible solution, if it is a possible solution, do one thing. First of all, let's pass all these variables. If it's possible, then put uh, right equals to mid minus 1. And one more thing, just make one answer and put this answer is equals to mid. If it is not a possible solution, then what we were doing, we were putting left equals to mid plus 1. And at the end, we were just returning our answer. So I think that's all what we can do. Let's see, is there any syntax issue? Work is slow, but cannot be converted to long. Okay, just take this as long. So the issue was that I was not converting that math dot square root into long. That's why it was creating an issue. Second thing, uh, we need to initialize the answer with the right because we are taking the worst case scenario first. That the in the worst case the answer will be equals to our right value that we discussed earlier. So now I will just submit it out. So yeah, now the answer has been submitted. So that's all for the video. Keep learning.